Great, thank you so much. So my name is Katie O'Connell. I'm from Georgetown University, where I work with my mentor, Abby Marsh. And today I'll be talking about our application of MBPA to study empathy for pain. So I study empathy, and more specifically emotional empathy, which is the ability to understand and respond to the emotions of others in appropriate ways. Emotional empathy has multiple component processes. The main one that I'll talk about today is this idea that we can affectively resonate or share in other people's emotions. Empathy comes so easily to most of us that we can often forget how important it is for social behavior. In the lab, we hypothesized that emotional empathy is pretty normally distributed throughout the population, where most of us would fall somewhere in the middle, and then there might be two extremes. So on the extreme low end of the emotional empathy spectrum, we might have a population of people who show antisocial behavior, such as those with psychopathy. But today I'm going to focus on what we hypothesized to be the group at the extreme other end of the spectrum, a group of people who engage in altruism. And so they engage in self-sacrifice for the well-being of others. So we study a special population of people who we think are on this extreme right end of the spectrum. And so many of you may know that it's possible to donate a kidney while living to another person. So in the US, about 5,000 to 7,000 of these living kidney donations occur per year. As you might expect, many of these the donors are relatives or spouses of the person who's receiving the kidney. But what some of you may not know is that there's also a population of people who donate a kidney to a stranger. So this is called altruistic living donation or non-directed donation, and about 300 of these occur in the US each year. There's probably about 700 in the UK, and then most other countries don't really report statistics. So these donors incur significant costs in order to make these donations. So they very often pay out of pocket for undergoing this procedure because it's elective. They experience 3 to 6 weeks of really intense post-operative pain. And they also have to undergo extensive testing prior to being able to donate, including psychological and medical testing. They really receive nothing in return, so they don't have any financial benefit for donating. In the US to date, there's about 2,500 of these altruistic kidney donors, and so we brought 28 of these donors to our lab, and our final sample after excluding for motion and MRI was 25 altruistic kidney donors and 27 age-matched controls. And we're interested in empathy for pain, and so when we brought these subjects to the lab, we had them undergo this painful pressure experiment. So they were titrated to a painful pressure that was slightly intense pain for them. And then we also had them briefly meet a stranger study partner who would also experience the same exact painful pressure stimulus. And the stranger study partner sat outside of the MRI room. The subjects then entered the MRI environment, and the task, so for the first run of the task, the subjects were observing their partner anticipate and experience this painful stimulus, all being cued by different audio tones. The second run of the task was the same as the first run, where they were observing their partner experience the pain, but there was an additional prompt to empathize. And then during the third run, the subjects experienced the painful stimulus themselves firsthand. And I don't have time to talk about the empathy prompt today. And so we're interested in where in the brain are there similar responses to experienced pain and observed pain. So to do this, we used a technique called multivariate cross-classification, which I'm sure many of you are familiar with. And so in this, we used a linear SPM classifier to try to distinguish between experienced pain from no pain. And I forgot to mention there's non-aversive control trials interspersed throughout each of the runs. And so we try to be able to discriminate experienced pain from no pain. And then using this exact same classifier, we then test to see whether it performs well on the observed pain versus no pain. And so if the classifier performs above chance, we can say that there's some informational similarity between experienced pain and observed pain. And we use this as an index of empathic resonance. We did this throughout the whole brain using a searchlight approach. And briefly, I'll just show you the group level results. So here I'm showing z-scores of where, so we used AUC as a performance metric, so where AUC was greater than chance. And I just want to note that we primarily replicate what previous studies have found, that areas like the anterior insula are showing similar responses to experienced and observed pain. But what we are actually interested in is whether there are group differences in these AUC maps. So is ecologically valid altruism associated with increased cross-classification between experienced and observed pain? Indeed, in the anterior insula, we did observe increased cross-classification in altruists relative to controls, which is shown on the left. And on the right, I am showing normalized SVM pattern weights, which indicate how distributed voxels carry information that's useful for our classifier. So they're distinguishing between pain and no pain events. So on the top, they're distinguishing between experienced pain and no pain, and then the bottom, observed pain and no pain. Basically, the yellow voxels are important for the classification. We also observed this similar result in the supplementary motor area, where altruists are showing increased cross-classification or increased similarity between their responses to experienced pain and observed pain. We didn't specifically hypothesize that we would see SMA, but SMA does come out in a number of meta-analyses looking at studies involving empathy. And we think this sort of correlational result with altruistic behavior provides a bit of support for the hypothesis that others have that SMA may be involved in the motor and behavioral response components of empathy. And that would be similar to the SMA's involvement in organizing behavioral responses to personally experienced pain. It may also be important for empathic pain. Just briefly, I want to talk about one complementary approach that we also took for this data. We were looking at how these response patterns relate to reported perceptions of pain experience. For this approach, we took anterior insula and SMA regions of interest, and from each voxel in these regions of interest, we extracted the mean activity during experienced pain and subtracted out the mean activity for no pain. So for each subject, we get one vector indicating responses for each voxel to experienced pain. Then I did the exact same thing for the observed pain condition. So looking at the same coordinates, we can do a simple correlation between these two vectors. So we get one correlation value for each subject that then gets converted to Fisher's Z. And so we're using this as, again, another index to look at empathic resonance. So I'll show the results for SMA for this analysis. And just to orient you to this graph, I'm showing SMA pain similarity on the y-axis. So a value higher on the y-axis indicates a higher correlation value or more similar responses to experienced and observed pain. And on the x-axis, I am showing the pain ratings, and specifically the experienced pain ratings, so how the subjects felt about the pain themselves, subtracting out how they perceived their partner to experience the pain. The first thing you'll notice is that the altruists in green show higher SMA similarity between self and other responses, which was totally expected because this is the same results as what we saw from the cross-classification analysis. What's really interesting here is that for each group, we see this relationship between SMA pain similarity and these pain ratings. So this is indicating that subjects who rated their own pain as being more intense than their partner's pain also exhibited reduced similarity in this region. Okay, just to go through a few conclusions. So we believe this provides some evidence that ecologically valid altruism is associated with more similar responses to experienced and empathic or observed pain. And so this is providing some support that this group of altruists may lie to the extreme right of this emotional empathy spectrum. And then we also observed a relationship between pattern similarity and reported perceptions of pain in both groups. in SMA, suggesting that this region may integrate information about perceptions of emotion to help inform behavioral responses, which in the case of people who have high levels of emotional empathy, could be in active altruism. And with that, I would like to thank my lab, especially my mentor, Abby Marsh, and our funding from John Templeton and NSF.